All right, good morning, good afternoon. Welcome to our next lesson. This one is our 6th lesson of Unit 2. Our summative is right around the corner, and today's lesson is all about, is it linear? And yesterday's lesson, the rate of change, is super important to this lesson today because we need to use it to look at some tables. So the first thing we're going to do is calculate the rate of change of these tables. I want us to kind of investigate, and this is going to give us a nice little beginning start to our Is It Linear lesson. So from yesterday, calculating the rate of change. So if I'm looking at x is 2 and x is 4, I'm looking at these 2 points. So I'll do 7 minus 5. Over 4 minus 2. 7 minus 5 is 2. 4 minus 2 is 2, and that equals 1. Go ahead and pause me and calculate the rate of change for the next 2, and unpause me when you're finished, or come back if you're stuck. All right, now we're looking between 4 and 5, so here and here. So we do 8 minus 7, and then 5 minus 4. Again, our equation is y2 minus y1, x2 minus x1. Eight minus 7 is 1, 5 minus 4 is 1, so I get 1 here. And then last one, we have between 5 and 8. So I'm looking here and here. So we have 11 minus 8 over 8 minus 5, 3 over 3, and that equals 1. Okay, so we have our rate of change calculated for all these 3. Now I want to look at this other table, table B, and we're going to do the same thing, and then we're going to make a prediction before we graph them. Alright, so go ahead now and do the same thing. I want you to pause me and calculate the rate of change between these 3 different sections here, and then come back when you are finished. Alrighty. I've gone ahead and finished calculating them, taking my second value minus my first value, y is on top, x is on bottom, and we got 4, 5, and 3. So between these 2 different tables here, this one, our rate of change, we calculated a 1 every time. This one, we got 3 different numbers. What do you think, which one of these do you think is going to be linear? And when I say linear, I mean make a line. If you think of the word linear, there's a root word in there, and that word is line. So between this one where our rate of changes were the same and this one where they were different, which one do you think would make a straight line? And we're going to actually figure that out right now. So I'm going to graph my table right over here. Let me actually get rid of this. There. That should help. Alright, let's go ahead and graph our points. So the first point we had was 2, 5. So that's right here. 4, 7. Right here. 5, 8. 5 to 8. And then 8, 11. Alright, and then connect it with a line. Go ahead now and graph the next one. Probably already know the answer to which one is linear, but let's go ahead and graph this one. Pause me, plot those points, and then come back and unpause me. Alright, so we had 0, negative 3, 1, 1. 2, 6, and then 3, 9. it's doing something real weird. 0, -3, 1, 1, 2, 6, and 3, 9. Yeah, that one's super funky. Oh no. Let me get rid of that. Here we go. Then it gets a little steeper and then shallower. Okay, so the one here that makes a straight line, no questions asked, is A. So the difference here is that A, you can see the rate of changes are constant. We have a 1, a 1, and a 1, versus this bottom one where we go 4, 5, 3. And that's one of our rules we're going to talk about today. For tables, in order to determine if it's linear, you need to calculate the rate of change. If your rate of change is the same every time, that means it's linear, it's going to be a line. So linear functions, there are 3 ways to determine if a function is linear. Just like above, we have the table shows a consistent rate of change. It is always the same. And I say linear, table A above. This one, we calculated a 1 every time. Versus nonlinear, table B. Our rate of changes were constantly different. The next thing we can do is look at a graph. To determine if it's linear, a line. You're simply just, does my graph look like a line? Then it's linear. So it makes a line. So this would be an example of a linear function. This one would be an example of a nonlinear function. And then when you're given an equation, you can tell if an equation is linear if it has no exponent on the variable, nor any division by a variable. So as long as there is no exponent on the variable or no division by a variable, it is linear. So this one would be linear right here because there's no exponent on my x, and then there is no division by a variable. This one is nonlinear because it has an exponent of 2 on my x. Okay, so let's go ahead and work through some guided practice here, and then you will go and do some independent practice. So I want to know, is this a function first? We have a 2, 3, 4, 5. All of my inputs are different. They all have one output. So yes, this is a function. And now I want to know if this is linear. So let's go ahead and pick 2 points, and we're going to calculate the rate of change. So let's do between x's 2 and 3. And then let's calculate the rate of change between 4 and 5 as well. Go ahead and pause me, calculate those rate of changes, and then come back when you're ready. Okay, so we calculated the rate of change here between x's 2 and 3, 9 minus 4, and then 3 minus 2, and we get 5. And then between 4 and 5, 25 minus 16, 5 minus 4, and we get 9 over 1, which is 9. So would this one be linear, yes or no? And our answer here would be no. And it's because, let me try zooming in here. And it's because our rate of change isn't constant. My rate of change is different between these two. If it was 5 and 5, then it would be yes. Okay. We have this one, -2, -1, 0. Is this a function? What do you think? Yes, it is. And then now, is this linear? Show your rate of change calculations. So again, same thing. Go ahead and pick 2 points. So let's say between -2 and -1. And then do between -1 and 0. Oh my goodness, come on. Okay, so calculate your rate of change between the top 2 points and then the bottom 2 points. Go ahead and start that and then come back when you're finished. Okay, so we have our rate of changes calculated for the top 2 points and then the bottom 2 points. We had -3 and -3. So is this one linear, yes or no? And this one would be yes, because our ROC, our rate of change, is constant. All right, now we just have some equations and then tables, and then you'll head on to independent practice. So we have equations next. Let's revisit our rules a second. So for equations, if there is no exponent on the variable and any division by a variable, as long as none of those are there, it is linear. So this one, we have 3x squared plus 5. Is this one linear? This one would be no, because there is an exponent on my variable. How about this bottom one? Do you think this one would be a function? We have 8 minus 4x. Again, the equation has no exponent on the variable or any division by a variable. It is linear. So we have 8 minus 4x. This one, yes, because there is no exponent on the variable and no division by a variable. Just plain and easy. All right, and then lastly, we have 2 graphs here. Is this a function? Yes or no? Remember our rule to determine if a graph is a function is the vertical line test. If you can draw vertical lines and it only crosses your graph once, all of these only cross once, then it is a function. So yes, this is. It passes the vertical line test. And then is this linear? This one, I think you guys will be perfect at. Yes. And this one would be linear because it makes a line. All right, same thing. Is this a function? Again, I can draw a vertical line at any point here, and it only ever crosses my graph once. So yes, this one is still a function. Is this one linear? Does this one make a straight line? Hopefully you can see that. No, this one is not linear. Does not make, what in the world? Not make a line. We have a curved exponential line here. Okay, so there is our examples. Let me get this open. All right, you have some independent practice problems left. So we have a table, some equations, some graphs, and then a challenge problem for those of you who need something a little bit harder. So again, tell me here if this thing is a function and then why it is or is not linear. Let me know if you have any questions and then complete your mastery check.